Hi, my name is Erik Weaver. I work for Western Digital, and I'm focused on the media and entertainment vertical. Today, I've got the guest, Josh Kolden, who's going to be talking a little bit about Avalanche.io, C4, and some other exciting things he's up to. Josh, can you tell us a little bit about you and Avalanche?
Sure. I come from a film background. I've done visual effects and post-production for about 25 years in the industry. Worked on, rather big films at big production studios. And recently decided to move over and focus on cloud technology for media production because there's a lot of confusion around it, and I had the opportunity to encounter some of these problems early on when cloud was still very new, and develop some, I think, pretty exciting solutions. And some of those solutions I've put together and packaged them and kind of open source them so that anybody can use them. And then another piece I've put into a new company, Avalanche.io, that hopefully will help people manage production assets and communicate better about file-based workflows anywhere in the world using the cloud, or even if they're not using the cloud, being able to interact with files in a way that's just much more reliable and easy to collaborate on.
Very interesting. So you said something about open sourcing some pieces. C4, I believe, is maybe the aspect of what you're talking about. I know that recently it became a SMPTE standard, one of the fastest through the process. I think it's called 2114.
Yeah. So C4 refers to the C4 ID system. So one of the big problems that we have when we're dealing with files in media production is that Hollywood's actually quite good at managing files as they're moving, but it's extremely heavy-handed and difficult. We get it done, but it's because we have lots of human beings in every stage of file transfer, recording, logging all the files that come off of set, logging what comes into editorial, people that specifically handle the files. And that's all fine, and that can continue and should continue to keep things organized, but the big problem is you start getting production that's more widely distributed, you start using cloud resources, you start encountering a problem with the fact that all of the files we use on computers today are identified pretty much by their location. So you say, like a URL in a web browser, you say, I want to go to this website, I want to go to this file, this path on this website, or on your file system, I want to go to this specific file at this specific location. So all of our software is built around this idea, all of our management's built around this, but it means that if one company organizes their file in one way, and another company organizes their files in a different way, it takes a lot of coordination, manual human coordination, to figure out what you're actually talking about. If you're talking about the same files, if you're talking about changes to the existing files or new files or what that might be. And it doesn't really, in itself, have any mechanism to exchange those files. Those are being solved by each organization. So the C4 ID system is an ID that has a standard format that's always 90 characters long. Some people will say it's a little bit like an MD5 hash, but it's longer and more stable, it's more secure, it can't be faked, and the benefit of it is that a file, if I have a file, and I have a C4 ID for that file, you'll have the same C4 ID for the same file, even if it's called something different, even if you got it from some different source. We'll always agree on what that C4 ID is, and we don't have to talk to any central server or even communicate in advance about it. We'll both be able to compute those IDs right from the file itself.
Okay, so it's not like a UUID or a registry-based system.
Right, we're not in UUIDs and UMIDs and other kinds of identification systems, as well as file names. Those are what we call assigned identification, where anybody can change that at any time. You can change it just like you can change a file name. So globally unique files, file IDs, are numbers, are guaranteed to be unique, meaning that two files won't collide and have the same number. But you might have the same file as I have, but we would have different globally unique file names for them. So C4 eliminates those kinds of questions. So now, if you have software running in the cloud and it says, I need to use these resources to render something or to transcode or whatever, it can talk in terms of C4 IDs. And where those files are is not part of that equation. So it can say, I need these resources, and leave it up to the file mover or some other tool that's responsible for making sure that those things are in the right place. But the where they are doesn't have to be answered by the production software.
So C4 then is kind of at the base of Avalanche.
That's right. So C4 is kind of a very fundamental cloud enabling tool, so that we don't have to know how to request files from different locations. So that was so important. I felt like that needed to be, open sourced. It was already part of the cloud solutions that I built for the work I was doing, but it was important enough and broadly valuable enough that I felt like we should just open it. We were able to get the SMPTE standard on it, and it seems like there's a lot of interest in uptake in it. So Avalanche then kind of helps take that to the user level and say, here's all your files as you expect to see them. Here's your production assets. Here's the stuff that's coming from, say, the DIT cart on set. And so you'll be able to see, did the files that were listed from what was coming on set, are they here? Doesn't matter if they've changed their name. Doesn't matter if you want to reorganize them in some way. You can always check the manifest of what's coming from set against, say, files that you have in editorial or so forth, and they'll line up if they're the same file. No, it doesn't matter. It's always safe to rename them or move them wherever you like in their file system. So it helps you connect the meaning of files to your file paths, one naming convention at one company to the naming convention of another company. It allows different people working in different roles, like a producer or a visual effects artist or an editor, to each have their own views, own naming conventions, however they like to organize things. But they'll all be pointing to this, potentially to the same file.
Almost a Rosetta Stone.
Exactly. It gives people an interface that's just a regular file navigator, but it's their point of view of the same data. So, and they're free to move things around, and you get to see all of your assets. So, typically in a movie production, you'll have potentially hundreds of terabytes, if not petabytes of data. And so this data is potentially located all over the world. But Avalanche, using C4, gives you that global view of all of your data wherever it is. And it allows users to attach relationships, say that this file has these notes with it, see logs of what's happened to the file. If you have a hard drive that's from some location but you're not sure what the files are, then if it's ever been seen before by Avalanche or C4, it can tell you where they come from, even if nobody put any notes with them.
So is this kind of like a MAM or a DAM, Media Asset Manager?
It's a little bit different. It's kind of a new tool. Since we've never had the ability to kind of uniquely identify files independent of how we're organizing and naming them, there really isn't a tool in the marketplace that's like this. Whereas a MAM and DAM will talk in terms of shots and revisions and things that are very production-centric and may have lots of tools for tracking specific assets, maybe elements of composite or other kinds of features. This can support that. A MAM would use C4 IDs, for example, to also be able to identify the same files. But Avalanche provides kind of a more fundamental view. You can put notes with it. You can do a couple of the things that you might think you can do with media asset managers. But fundamentally, it's trying to just give you this intuitive file management point of view and let all the different software tools we're already using in production function the way they normally would. It's not really taking any of those kinds of responsibilities. Instead, it's enabling, say, this asset manager that maybe this company uses over here to communicate in a consistent way with a completely different asset manager at a different company for a different purpose.
The rise of mammification. I heard someone talking about that the other day. So talk about imperative versus declarative and the concept behind this.
Right, so this is one of the kind of exciting developments, introductions of new technology that Avalanche is incorporating. So most of the time when we think about moving files around, we think imperatively. And what that means is we say, I'm going to download this file right now. right? I click on the web browser, I find the file I want, I click the button to download it, and it downloads right then. And if something gets interrupted, the network connection gets interrupted, if anything happens, it's kind of on us to just initiate that download again. Sometimes there's a few software tools that'll try it a few times, but that's just automating this imperative process of like, I need to get this downloaded. What Avalanche does is what's called declarative. And so the way it works is because Avalanche needs to be able to have a view of files without necessarily moving them, it's talking about terabytes and terabytes of data that is distributed around the world, you want to be able to interact with these things without using like file syncing and stuff where you pull all of these files down necessarily. You may want to, but you don't have to. You want to be able to talk in terms of like, I have this set of files in this location, and I want to organize them in a certain way. So each of those different locations, you can just say what files you want to be there. You can say, take all these files from this hard drive that was on set. You could be, in your home office using your desktop machine and copying and renaming and organizing files that are being sent from LA to London, and they haven't even arrived in London yet, right? They're in transit, but Avalanche has a view of what they looked like when they made it onto the hard drive that's being shipped. So you can start moving these files around. It's not happening right at that moment, not like downloading a file. It's much more like editing a document. So you have all these folders and files, and you just move them around like it's a text in a word processor. So you copy, paste, move your files around, organize them, rename them, whatever you want. And then when the data, what happens in Avalanche is it just works forever to make that true. And if it doesn't have the file yet, either it has a mechanism of getting it, or if it doesn't, it just waits. And if it shows up one day, it puts it in that spot. And in that way, a lot of these kinds of very dynamic production workflows which most tools can't handle, most computer-related software management tools just can't handle, like even MAMs is a good example. MAMs typically will take the assets or thumbnails of the assets and actually ingest them into the MAM so that it knows where they are, right? Avalanche doesn't have to do this. You say, I want these files in my home directory on my laptop. And it goes about, it won't happen, it may happen immediately if it knows where all those files are, but if not, it will just keep trying indefinitely until that's true. So it makes things much easier to manage because you don't have to worry about connectivity. You can continue to make changes even if it never did download that one, and now you want to put it somewhere else. It's always sees a single view of what you intend to be happening.
So it takes some of the brittleness out of the work.
And yeah, exactly. It takes all of these moments of just, did it really download, or any of those kinds of things out of the
Or has the
problem.
file path changed, or
Right.
other things that could,
Right.
or
And
was
it always
renamed?
looks
Yeah.
exactly the way you've basically said that you want it.
So that kind of leads us into the next thing is we're really excited because we're putting the product in between our G-Rack and our ActiveScale series. Do you want to talk anything about that or share some of that work?
Yeah, I'm actually really excited about this because Avalanche is very specifically designed not to be strongly bound to any hardware so that it can work in production environments. It doesn't require a special piece of device that you plug in to make it work. In fact, you can have it working on your laptop with no network connection at all. Important in high security areas. But what that means though is there's a missing part that we'd like to have, which is tools that kind of automatically generate C4 IDs, automatically start moving things into different places where you want to. And this is an excellent use case where we have taking the C4 engine, the back end of Avalanche, and putting it right on a G-Rack device so that it's sitting there always in the background, making sure it has a fresh view of what the file system on the G-Rack looks like. And if you have a P100 object store, it will also do regular policy-based backups or snapshots of these file structures. And there's a lot of really cool features just in the open source quality of C4, but obviously Avalanche takes advantage of them. Allows files, for example, to be uploaded to the P100 throughout the day. As things change, you can be uploading them. It doesn't have to, like you might think of normal backups, where there's a single point in time, let's say 2 a.m., and it crawls through the entire file system and uploads everything at that moment. Because C4 and Avalanche knows what the ID of a file is, it can look on the P100 and see the file's already there. I don't need to copy and make another copy of it. So by the time it gets to 2 a.m. and it's ready to mark the snapshot, all that's left is to say which files have which IDs, but most of the data has already been moved. So that makes snapshots in this setup almost instantaneous. They're extremely fast and very low overhead.
So how do you see this affecting cloud or object storage?
So it's been a little bit challenging to use object storage up to now, and there's this association with object storage as a cloud storage, but you can have object storage in your own data center, and what's been missing is just an effective way to incorporate it into production. And Avalanche provides a mechanism to use the object store just like a regular file system. And it can provide, snapshotting and archive features for GRAC with this connection, and I'm excited about that integration. And overall, just making it more accessible for regular production people to be able to see their assets and not to go through a web interface or some kind of unusual workflow.
Excellent. Well, thank you so much for your time. Really appreciate it. And we hope that you reach out to us if you have any questions around any of the solutions. Thank you so much.